information in the memory of the quantum computer safely, robustly.
For decades, computers have been getting faster, smaller, and more powerful, but even the fastest supercomputers still use the same old binary logic. They process info by flipping tiny electrical switches between ones and zeros. It's efficient, but it's also pretty limited. Well, that's all about to change. Something huge has just happened that doesn't just push the limits of computing, it completely breaks it. Well, who is at the center of this revolution? According to sources, Google's latest quantum chip. Yes, Google has its very own quantum chip. This thing has capabilities we once thought were pure science fiction. Quantum computing is about reshaping our understanding of the universe itself. Renowned physicist Brian Cox warns that Google's latest quantum chip discovery doesn't just push the boundaries of computing, it could unlock the very laws of reality. So, what exactly did Google uncover, and why are some of the world's top scientists both amazed and alarmed? How quantum computing defies classical limits. So, no matter how powerful traditional computers are, they still follow the same basic rule: binary code. At their core, they're just flipping between ones and zeros, like tiny digital light switches. That's how your smartphone runs apps, how supercomputers analyze insane amounts of data, and how AI processes information at breakneck speeds. Solid? Yes. Fast? Definitely. But there's a hard ceiling to what they can do. Now, let's say you throw a mind-bending problem at a regular computer, like simulating an entire molecular reaction. It has no choice but to grind through every possible outcome one by one, step by step. And if the problem is ridiculously complex, that could take millions of years. Literally. As for quantum computing, these machines work with qubits instead of the usual bits. What makes qubits interesting is that they don't just switch between 1 and 0, they can be both at the same time. Sounds impossible, right? It's all thanks to a wild quantum effect called superposition. Think of it like solving a maze. A regular computer would take the old school approach, checking each possible route one after another until it finds the exit. If the maze is simple, no problem. But if it's massive, it will take a while, right? A quantum computer, though, is a whole different story. Because qubits can exist in multiple states at once, it doesn't have to test every path individually. It evaluates all of them simultaneously. As a result, we can get our answer almost immediately, and it gets even crazier. Thanks to something called entanglement, qubits can be mysteriously linked, no matter how far apart they are. This means quantum computers can blaze through calculations at speeds that make today's fastest supercomputers look ancient. Sounds like sci-fi, right? But it's happening right now. And Google's latest quantum chip breakthrough? It could change everything. While quantum computing is changing the game, it's also cracking open the door to some serious risks. Think about it. Your bank account, private messages, even top-secret data, all could be vulnerable. Why? The dark side of quantum computing. However, as much as quantum computing might sound like something straight out of sci-fi, it's proving its reality to us day by day. Super-fast calculations, mind-blowing discoveries, and solving problems we used to think were impossible are now made possible. Sounds great, right? Well, not so fast. As Brian Cox has pointed out, there's a side to this tech that's actually pretty terrifying when you think about it. Right now, everything online, from your bank details and private messages to even top-secret government files, is locked up using encryption, right? Well, in most cases, encryption is so advanced that even the fastest supercomputers would take millions of years to crack it. Well, that's because it's built on ridiculously complex math problems, and so far, it seems to serve us just right, until quantum computers came into play. Yeah, these machines don't play by those rules. Instead of working through problems one step at a time like regular computers, they process insane amounts of data all at once. That means a powerful enough quantum machine would do more than just break today's encryption. It would destroy it in seconds. In just a matter of seconds, you can say goodbye to your privacy. Your passwords can be veiled in seconds, including exposing sensitive information like government secrets. With quantum computing, we can't just assume that it's some minor tech upgrade. Technology like this changes everything. Cybersecurity, as we know it, will be pretty much useless. And if this technology falls into the wrong hands, we're looking at a digital apocalypse. A glimpse into the future of reality, ethics, and control. Quantum computing doesn't just hold the promise of speeding up calculations and solving problems that classical computers can't. The potential impact of quantum computing reaches far deeper into the very fabric of reality itself. You see, quantum mechanics, principles like superposition, entanglement, and the observer effect are more than just abstract ideas. These concepts form the backbone of how quantum computers work. When we harness these principles, we're not just crunching numbers, we're engaging with the fundamental laws of the universe. But here's where it gets unsettling. One of the most provocative ideas is that quantum computers might eventually be capable of simulating reality itself. Think about that for a second. We're talking about computers so powerful that they could potentially generate highly detailed, lifelike simulations of the universe. This concept ties directly into something known as the simulation hypothesis. The idea that if we can create simulations that are indistinguishable from reality, how can we be certain our own reality isn't a simulation? It's a philosophical question that's been debated for years, but as quantum technology advances, it's becoming more relevant than ever. The possibility that we might simulate reality itself is no longer confined to sci-fi movies. It's something that could actually happen in our lifetime, but the implications are staggering. For one, privacy, already hanging by a thread in the digital age, could disappear entirely. Imagine if highly accurate simulations of human behavior became so detailed that governments or corporations could predict and even manipulate individuals or entire populations. This could happen on a scale we've never imagined before. With quantum computing's power, we could see a future where the ethics of control and privacy become blurred beyond recognition. As we stand on the brink of what many call a quantum revolution, the ethical questions are mounting. Who should have access to this kind of transformative technology? How do we ensure it's used responsibly? And perhaps most urgently, what safeguards can we put in place to ensure it doesn't fall into the wrong hands? As quantum computing moves closer to reality, these are the questions that scientists, policymakers, and ethicists must grapple with, because once that door is opened, there may be no going back. Quantum computing, a turning point for humanity. Now, let's talk about the bigger picture for a second. Google's new quantum chip is not just another extraordinary tech breakthrough. This kind of technology is a game changer for humanity. Seriously, this tech could change everything we know or thought we knew about our world. From how we protect our personal data to how we start exploring the universe, all this could be done in a matter of seconds. You might think quantum computing is all high-tech labs, distant futures, and way over our heads. But, as Brian Cox puts it, it's already messing with some pretty basic ideas we've been taking for granted. Take security, for example. With this tiny quantum chip, we will be able to change the way we look at encryption and the way we keep our information safe. And that's just the tip. Even how we think about the very fabric of the universe will change. But here's the catch. With all this power, there's a huge responsibility. Sure, quantum computing could do some incredible things. Medicine, renewable energy, space exploration, you name it. Imagine being able to simulate how molecules behave with crazy precision, or developing new materials that could change industries overnight. It could even help us fix some of humanity's biggest problems, like curing diseases or solving food security issues. The possibilities are endless. But, and this is a big but, as great as all that sounds, it also comes with some serious risks. These systems could get so powerful that they start shifting the balance of power on a global scale. Plus, we're talking about some huge ethical dilemmas, like who gets access to this tech and what happens to privacy. It's not all sunshine and rainbows, and that's something we've got to keep in mind. The decisions we make now are going to shape how we handle this tech in the future. Will we take our time, think it through, and be responsible? Or are we just going to charge ahead and risk missing the bigger picture? These are the questions we really need to answer as we step into this new era. As Brian Cox says, quantum computing could be humanity's most significant tool or its biggest challenge. It's up to us to decide how we use it, and how we handle the world it's going to create. As powerful as quantum computing is, it could also shift the balance of power in ways we can't predict. What happens when the tool that can save us also threatens everything we've built? A revolution of promise and peril. So, quantum computing is basically the ultimate double-edged sword. On one hand, it could be the key to some of humanity's biggest breakthroughs. Imagine accurately predicting climate change patterns, simulating entire economies, or cracking the mysteries of the human genome in seconds. Stuff that traditional computers just can't handle because, well, they hit a wall with their processing power. But quantum? Oh, it smashes straight through that wall like it's nothing. But here's where things get a little terrifying. The same insane computing power that could, say, revolutionize medicine or solve global food shortages could also be used in ways that are, let's just say, less than ideal. We're talking about the ability to break even the toughest encryption. So yeah, all those security systems we rely on, potentially useless. And if governments and tech giants don't handle this responsibly, we could be looking at a whole new kind of digital arms race. And this isn't some distant sci-fi future we're talking about. Google's new quantum chip, it's already forcing scientists, policymakers, and, well, anyone who understands what's happening to rethink everything. We're no longer just asking, what can this technology do? But also, are we actually ready for what comes next? Because let's be honest, history hasn't exactly been great at handling disruptive tech, and when you're dealing with something as powerful as quantum computing, the stakes have never been higher. The privacy crisis. Now, things start to get a bit scary when you start touching on people's privacy. And I mean serious, world-changing kind of scary. Right now, all our sensitive data, which includes bank transactions, medical records, and even top-secret government stuff, is locked away, using encryption based on some really tough math. The kind of math that classical computers struggle with, but not quantum computers. Yeah, they don't struggle. In fact, they absolutely smash through these encryption protocols like they're made of paper. Google's new chip has proven that this isn't just some sci-fi scenario, but a real-life occurrence. Now, as you can imagine, the consequences of such advancements are massive. Financial institutions, hospitals, and governments rely on encryption that quantum computers could soon break.
How quantum computing can attain an advantage? By performing computations in parallel worlds.
That means private data, even state secrets. Everything could be up for grabs. And that's not just a theory. It's already changing global strategies. Countries are now scrambling to develop quantum-proof encryption. But here's the problem. It's going to take years to roll out properly. And in the meantime, the world is exposed. Now, imagine if a rogue nation or just some dodgy hacker group gets their hands on a quantum machine before we've got defenses in place. That's when things get really dangerous. Economies could collapse, democracy could take a hit, and we wouldn't even see it coming. This is why Brian Cox and other scientists are sounding the alarm, because quantum computing isn't just about progress, it's also about control. And right now, the race is on to make sure this doesn't fall into the wrong hands. But here's the thing, privacy isn't the only concern scientists have. There's an even bigger question lurking in the background, and that is, who actually controls this power? I mean, should anyone, whether it's a tech giant, a government, or some shadowy organization, have the ability to access and potentially manipulate basically everything? Bank records, medical histories, classified intelligence, you name it. These questions demand urgent attention. The nightmare doesn't stop there. If you think quantum computing is scary on its own, just wait till you see what happens when you combine it with AI. Quantum-enhanced AI. Now, let's get into something really mind-blowing. It might even sound futuristic to some. Quantum-enhanced AI. Yes, you heard me right. AI is already changing the game in almost all industries, automating jobs, analyzing massive amounts of data, and even creating personalized experiences. But when you combine AI with quantum computing, things start getting wild. Picture this. a quantum-powered AI system could crunch through vast and complex data at speeds that even the best supercomputers today can't even get close to. When we talk about quantum computers, we're talking about machines that can learn, adapt, and evolve at speeds that are completely beyond human comprehension. Now, something with such immense potential, combined with another powerful integration, sounds dreadful if you ask me. Imagine an AI that can analyze billions of data points and predict trends with near-perfect accuracy, all in a matter of milliseconds. Not seconds, milliseconds. Well, in healthcare, this could be revolutionary. It could detect diseases way before symptoms even show up, and tailor treatments to individuals with precision we've never seen before. Sounds impressive, right? However, this same tech could also be used to manipulate human behavior, predict societal trends, or even influence elections. From the sound of things, we're walking a very fine line between innovation and exploitation. And then there's the whole question of autonomy. With quantum-enhanced AI, decisions that used to be made by humans could start getting handed over to machines. On the surface, actually sounds like a good thing. Given the fact that machines don't have emotions, they don't get tired, and they don't make irrational decisions. But here's the catch. What happens when these AI systems become so complex that even their own creators don't fully understand how they work? Like, who's accountable when a quantum AI makes a mistake? Or worse, what if it deliberately acts against human interests? And that's not the worst part. Imagine quantum AI being used to power autonomous weapons. These machines wouldn't just follow commands. They'd analyze enemy movements, predict strategies, and deploy countermeasures in real time, faster than any human general ever could. Sounds efficient, but here's the terrifying bit. You're basically removing the human element from life and death decisions. So, at that point, we're talking about wars being fought not by soldiers, but by algorithms. And that? Yeah, that's a very scary thought. Quantum computing, redefining the future of humanity. Alright, let's dive into what this all means for the future. Quantum computing isn't just about AI or encryption. According to Brian Cox, it can potentially change how we understand the universe itself. Brian emphasizes that quantum computers have the ability to simulate systems that regular computers could never handle. They could help us explore things like quantum field theory, which explains particle physics and phenomena such as quantum entanglement or the Casimir effect. These discoveries could completely reshape everything we know about how the universe works. But here's where it gets even crazier. If quantum computers can simulate reality down to the finest detail, what does that mean for our own reality? Could we be living in a simulation created by some advanced civilization with tech so far beyond us? I know this sounds like something straight out of a sci-fi movie, but as Brian Cox points out, this is a real, serious question now. The simulation hypothesis isn't just a fun debate, it's something that quantum computing is now bringing closer to being true. Wild, right? Navigating the challenges on the road to mainstream adoption. Now, stepping away from its philosophy, there's a much more immediate question we need to address, and that is, what happens when quantum computing starts reshaping the global balance of power? Throughout history, huge technological advances like the steam engine, electricity, and even the internet have reshaped economies and even global politics. But now, quantum computing could be the next big thing. With continuous technological advancement, it's only a matter of time before countries crack the mystery of quantum computing. Countries that crack quantum supremacy are going to have a massive head start in things like cybersecurity, military strategy, and even predicting the future of economies. And guess what? Nations are already pouring billions into researching the technology. However, there's always a catch. This race to understand quantum technology isn't just about who gets there first, but what they will do with it. Will quantum tech benefit everyone, or will it just become a tool for a select few to lock in power and wealth? That's the big ethical question we need to face as quantum computing becomes increasingly a reality. Now, despite all the excitement surrounding the launch of Google's new quantum chip, it's important to remember that this technology is still quite alien to man. It's like we're opening up a huge door to infinite possibilities. However, we're still unsure of what to expect once the doors are open. Well, that is before we see quantum computers in every lab, office, and home around the world. First off, let's talk about the challenge of scalability. Sure, Google's chip is impressive, but it's just the beginning. Building quantum computers that can handle thousands or even millions of qubits can be a huge challenge. Even for tech giant Google, it's going to take a lot of investment in research, materials, manufacturing, and how we even approach computation.
They don't even completely understand how this is working.
This is no easy feat. Think of it as upgrading a regular car to a rocket ship. That's not all. Google also has to develop proper error correction methods. Quantum computers are super sensitive to their environment. That means that any slight disturbance, whether it's a vibration or a temperature change, can mess things up. Researchers have made progress with error correction algorithms and improving hardware stability. But the truth is, we're not there yet. It's like trying to build a car engine that runs smoothly in every weather condition. It won't happen overnight. And let's not forget about the challenge of sustainability. Quantum computers require a ton of energy to run. We're talking about keeping things at ultra-low temperatures, which isn't exactly energy efficient. Given the world's growing concerns about climate change and resource scarcity, we really need to think carefully about the environmental impact of this technology. Quantum computing has massive potential, but realizing that potential isn't going to be a walk in the park. There's a lot of work that needs to be done in order to tackle these hurdles. And let's face it, it's going to take a careful balance between pushing forward with innovation and ensuring we're doing it responsibly. The road to mainstream adoption of quantum computing is a rocky one. Still, if we manage to navigate these challenges, the rewards could be game-changing. Even with all its potential, quantum computing isn't just about breakthroughs. It's about the choices we make. The path ahead is tricky, and how we approach it could change everything. So, what happens next? A revolution in our hands. So yeah, as we can see, quantum computing is not just another fancy bit of tech. It has the potential to change everything. From curing diseases to cracking the mysteries of the universe, this technology could reshape our world in ways we can't even begin to imagine. But power like this comes with massive responsibility. If we manage to harness it right, we could be looking at a future we only thought was possible in sci-fi films. However, if we get reckless, let's just say things could get very messy very quickly. And that's exactly what Brian Cox is trying to tell us. Google's quantum chip isn't just an impressive piece of engineering. It's a wake-up call, a reminder that technology isn't just about progress, but about the choices we make going forward. Will we use it to build a better, fairer world? Or will we let it widen the gaps and introduce us to risks we're not ready for? Right now, we're standing at the edge of a revolution in our hands, and the way we handle it is going to shape the future for generations to come. But the real question still remains, are we ready for it? Quantum computing, revolutionizing the world of biology and beyond. The possibilities of quantum technology are endless. Most, if not all, of the industries have something to gain from the technology. But we want to know how quantum computing is about to shake up the world, beginning with biology. We have to understand that this isn't just an upgrade in tech. This is a complete rewrite of how we process and understand life itself. The classical computers we have right now struggle when it comes to simulating molecules. Well, this is because molecules don't just follow simple rules. Their behavior is all quantum, all exponential, and regular computers just can't keep up. But quantum computers, they play by the same rules as these molecules, which means they can simulate them with insane precision. And why does that matter? Well, drug discovery, for one. Right now, finding new medicines is like throwing darts in the dark. Many health agencies and organizations are in constant trial and error. They are spending billions of dollars just on medicinal research. But with quantum computing, scientists can virtually test how different drugs interact with proteins electronically, even before they touch a lab. This could save development time and significantly cut costs. We're talking about potential cures for cancer, Alzheimer's, and even rare genetic disorders. Sounds cool, right? And it doesn't stop there. Imagine a world where your treatment isn't just based on what worked for someone else. Rather, it's tailored to your exact DNA. Quantum algorithms could analyze your unique genetic makeup and predict exactly how your body would respond to different treatments. No more one-size-fits-all medicine. This is healthcare, custom-made just for you. Talk about futuristic, but that's just the beginning. Quantum computing isn't just changing biology, it's reshaping everything. The way we study climate change, the way we model economies, even the way we think about free will. Yeah, let's not get too existential here. The bottom line is that this isn't some futuristic fantasy. It's happening right now. And with Google's new quantum chip, we're not just on the edge of a breakthrough, we're already stepping into a new era. Quantum computing and the planet. Right, so we've talked about how Google's quantum chip could shake up our security, biology, and even reality itself. But here's something you might not have thought about. What if it could help save the planet, too? Yeah, quantum computing isn't just some futuristic tech for scientists in lab coats. It could be a game changer for tackling real-time global issues like climate change. Predicting climate change is ridiculously complicated. There are just too many factors at stake. Factors such as carbon levels, ocean currents, deforestation, and even tiny shifts in global temperatures make it almost impossible to predict climate patterns. The traditional computers we are used to do a decent job, but they can only process so much data at once. Hence, their predictions aren't always spot on, but a quantum computer can crunch through way more variables way faster and give us insanely precise climate models in a matter of minutes. We're talking about simulations that are so accurate that they could predict what happens if we plant more trees, cut emissions, or even mess with the ice-filled lands at the North Pole. That means governments and scientists could make decisions with actual certainty instead of just educated guesses. And as if that's not enough, quantum computing could supercharge renewable energy too. In some parts of the world, scientists are already using quantum simulations to design better solar panels and batteries. They aim to create ones that capture and store energy way more efficiently than we currently have. Imagine batteries that can hold a charge for weeks instead of hours. Mind-blowing, right? This is next-level stuff, and it could speed up the shift to clean energy in a huge way. So yeah, quantum computing might just be our secret weapon against climate change. But the question is, will we use it wisely? Or are we just going to let this breakthrough sit in a lab while the world keeps heating up? Are we ready? So, as we stand at the edge of a technological revolution, one thing remains constant, and that Google's quantum chip isn't just an incredible piece of hardware. It's something that could shake the foundations of our world. And that's no exaggeration, but what does that actually mean for us? Well, for starters, the security of our information online should be considered. Right now, everything from your bank details to military secrets is protected by encryption. And as much as it can be secure enough for us right now, with quantum computing, all that will be broken in seconds. That means entire financial systems, government databases, and even personal information could be up for grabs. According to Brian Cox, whoever cracks quantum computing first holds the keys to a whole new level of power. Then there's the financial side of things. Quantum computing could make financial modeling insanely precise. Imagine predicting stock market trends with near-perfect accuracy. Hedge funds would kill for that kind of power, but what happens when a handful of companies or governments control it? Wealth concentration on a scale we've never seen before. The gap between the ultra-rich and the rest of us? Yeah, it could become a canyon. And let's not forget about AI. Do you think artificial intelligence is impressive now? Throw quantum computing into the mix, and it could make today's AI look like a toddler with crayons. We're talking about machines that could solve problems even the most brilliant human minds can't wrap their heads around. New medicines, climate solutions, and even answers to some of physics' biggest mysteries. But again, who's in control? Because if the wrong hands get hold of this tech, the risks are enormous. So here's the big question. Are we ready for this? Quantum computing isn't some distant sci-fi fantasy anymore. It's happening. And like Brian Cox keeps warning, it's not just about the tech itself, but how we handle it. Because this isn't just another step forward in computing, this is a new era, a turning point. And once we cross that line, there's no going back. Thanks for watching yet another video. See you in the next one.